So I'm from Datum Electronics, and what we've done is we've brought a small selection of transducers and products that we make which use micromeasurements gauges within them. Datum Electronics has been developing and manufacturing transducers for industry since 1989. We have a very good, long-established relationship with micromeasurements.
Yes, and I've been talking to you and your engineers for most of those years that you've been in business.
Exactly. So Anton knows us very well. The management team at Datum work very closely with micromeasurements. We know that they have the expertise. When it comes to strain gauges, we know we can pick up a phone and we can ask advice. We use some of their standard products, covering the whole range, but they also make bespoke gauges from our own design for certain applications that we have.
And I've spent some of those years talking to development teams and come up with custom designs for specific applications.
Yeah, so if we run through the products that we have on the table here, we have a selection of what we call bolt-on strain sensors, and these are used extensively throughout a lot of different industries, mainly the automotive industry and for things like silo weighing applications.
So these are designed for very simple installation processes?
Yeah, the basic idea behind it is to introduce a very simple way of installing a strain gauge where a customer needs to measure strain or load, for example on a vehicle axle, but they are not experts in installing strain gauges. So we take the pain of that away and simplify it into a full package, so a one-off solution that they can simply just bolt onto the structure.
Yeah, so this avoids all the installation process for a standard strain gauge,
Exactly.
which may be difficult to achieve in a field environment.
Exactly, and also on assembly lines. So some of these sensors we're supplying in many thousands every year in very, very high volumes, and for customers who want to have a quick solution where they have just a guy on a production line who's installing gauges for, say, a load monitoring application. It's very quick. There's 2 bolts or 3 bolts, very quick solution, and they get the output that they need.
And you were telling me earlier about this particular transducer, about how this is designed to overcome thermal transients for false alarms on an application.
Yes, exactly. So using a simple principle, we were able to overcome things like thermal changes or rapid changes in temperature, again on things like vehicle gearboxes and axles. So when a rapid change in temperature occurs, this sensor stops the alarm going off because it cancels out the...
Yeah, so essentially you have one active part of the sensor and one dummy part.
Correct.
That eliminates that thermal transient.
Very simple to install again. We have a variety of designs, and what we do is for our most of our customers are buying in very high volume, so we will, in that case, we will design a sensor specific for their application. So, but we also have off-the-shelf designs as well, which they can use for testing and establishing what is the right strain gauge sensor for them. Mm-hmm. So, yeah. So if we move on to the other part of our business, so we cover not just bolt-on solutions, but torque transducers and shaft power measurement, for example, in the marine industry and industrial applications, mixers, pump testing, motor testing, things of that nature. So we have standard off-the-shelf designs. All of these are available off the shelf. This one here is probably our most popular design. This is the M425. It's available from 10 Newton meters up to 60,000 Newton meters off the shelf, standard design, and we call it the Model T Ford of the industry because it is what it is. It looks like a torque transducer, and it is a torque transducer.
And this is using standard torsion strain gauges for micromeasurements.
We use the high accuracy transducer gauges that,
transducer classes
that
is
you
our
guys
trade name for those types of strain gauges.
That's it, exactly it. We use a design which gives us a very accurate output, straight through shaft. Gauges are applied in the factory. They're completely non-contact. The only contact between the shaft and the exterior is some bearings purely to support the body of the transducer. But we use state-of-the-art electronics, completely up to date, and no slip rings. And as Anton said, we use micro measurement gauges throughout all of our transducer products, simply because they're very reliable. The guys, they know what they're doing. The product it's a great product, and we get all the expertise and advice that we need when we need it.
And strain gauge, of course, they follow exactly what the transducer is doing. So you get high accuracy, very good thermal responses.
Very repeatable as well.
Yeah,
so especially on...
Very reliable for long-term applications.
Yeah, they'll last 30, 40 years without any intervention.
Using our standard accessories and installation processes.
Absolutely, and we've got transducers which have been out there for 30 years plus. They come back for calibration annually, and they're exactly the same as they were on the day they were manufactured.
To proper specification after 30 years installation.
Still working, yeah. So we know that it's one of the reasons why we've stuck with strain gauges, not just because it's an old technology, but it's also for the future as well, because the electronics that you use to condition the strain gauging can be brought up to modern times, and you can do a lot more with it. But you're using a strain gauge which is an established technology, which is known and understood,
yes.
well proven, so everyone knows that it works.
Yeah.